Corona Video 15, Parallel Circuits at BHS, the Stanford of the MVL. Today we're going to look at parallel circuits. The big difference between a parallel circuit and a series circuit is that you have more than one way to get back to the battery. So let's say that we have a battery and it has 6 volts. And let's say that we put 2 resistors in between the beginning and the end of the battery. These resistors are now going to be placed in parallel. Notice the branch and the wires. And then we'll have a resistor here and a resistor here. Let's say that this resistor has a resistance of 9, and let's say this resistor here has a resistance of 2. That would be a parallel circuit. Now, one of the things you have to understand about a parallel circuit is that they will have different currents. So the amount of current here will be different than the amount of current here, but they'll have the same voltage. So the voltage in the 9 ohm resistor will be the same as the voltage in the 2 ohm resistor. Now, when we start to try to figure this out, we have to find something called the effective resistance or total resistance. So the idea is that we're going to take this circuit and we're going to redraw it. And this time around, we're only going to have one resistor. This is going to allow us to find out how much current is in the battery. So what would be this one resistor? Well, we have to know how to deal with resistors in parallel. So the way you do it in parallel, rather than just adding them all up like in series, is we say 1 over the effective resistance is going to be equal to 1 over each of the resistors. And it would just keep going on. Now, when you only have 2 resistors, like we have in this case, it's even easier. You can kind of rearrange it. And we can say the effective resistance is going to be equal to the R1 times R2 over R1 plus R2. So that's how you do it for parallel. Remember, in series, you just add them up. In parallel, you add up the inverses. But we can shorten it down to this expression. So if we take the example here, we had a 9 and we had a 2. So if I say 9 times 2 over 9 plus 2, we would get 18 elevenths. And 18 elevenths would be 1.63. So the effective resistance of both resistors added together would only be 1.63, which is very different than if we ran these in series. If we put a 9 and 2 in series, we would get 11 ohms. Here, we get 1.63 ohms. So you can see by adding another path, it drastically reduces the resistance. So the bulbs will glow brighter, there'll be more current, etc., etc. So now that we know the effective resistance is 1.63, once we have that figured out, then we can go through and we can solve for the current in the battery. So to do that, we have to use Ohm's law. So Ohm's law, once again, V equals I times R. We can put in our effective resistance, 18 elevenths, and then we could put in the voltage of the battery. This time it was 6, and we could solve for the current. So 6 over 18 elevenths, 1.63, is 3.68. So that's how much current is flowing through the battery, 3.68 amps. So if we go back to our original drawing that we had at the beginning, I could write in the current in the battery. Now remember, these wires are ideal. And what that means is there's no resistance. So 3.68 starts here, right, and flows through the wire until we get to there. And then we have a break. And because there's a lot more resistance on the top part of the circuit than the bottom, most of it is going to go through here. And just a bit is going to go through here. But then it's going to come back together and be just like it was before, and then finish back at the battery. So most of the current goes through here, some goes through here. Now the thing they have in common is they'll have the same voltage. See this break right here? The push at the break is the same for both. So the voltage for the 9 will be the same as the 2. So that's our saying. For parallel, we have the same voltage. Series, we have the same current. So parallel circuits have the same voltage. Series circuits had the same current. So guess what? Ohm's law yet again. So this time around, for Ohm's law, we're going to use it to find the voltage at the break. So let's think about it. Ohm's law is V equals I times R. We can put in the effective resistance of the parallel part, which we just found was 1.63. So both of these together is 1.63. And we can put in the current coming into the break. The current coming in the break was 3.68. So if we multiply those together, we get 6. That's because there's only 2 circuits, or 2 resistors in this circuit. So if we have 6 volts here, that means we would have 6 here and 6 here. Now you might be thinking, back in our series circuit, we could add up the voltage and we would get the voltage of the battery. Here we would get twice as much because there's 2 paths. So that test doesn't work anymore for parallel. So now that we've done it for the voltage, we can now go back through and use the voltage and the resistance to find the currents. So we say V equals I times R. And we can put in the individual resistances, 2 and 9, and the voltages of 6. They both have 6. And then we can solve for their individual currents. So we can say 6 divided by 2, we get 3 for here, which is what we expected, right? Most of it's going to pass through here. And then we can get 2/3 here for this, so 0.67. Would have saved 0.68, so it comes out nice. Okay, so it breaks up. Most of it goes through the 2, some of it goes through the 9, and when we come back together and add this together, we get how much we had when we went through, 3.68. So my current would be 3 and 0.68. Add that backwards. 3.68. Okay, remember, most of it goes to the 2. 3 and 0.68. And that's how we have it go through the circuit. And that's how a parallel circuit works. So we'll talk about a combo on it in the next video, where we have parallel and series put together.